This is such an honor to present the man on whose science has led to a healing on such a massive scale. It's just unbelievable. Tonight, Dr. Campbell comes to us with 60 years of research under his belt. His primary focus has been on the association between diet and disease, particularly cancer. Dr. Campbell's probably best known for the bestseller, The China Study. You've sold over 3 million copies in 50 languages. That's a lot of books. He has several other books he's authored. He's delivered hundreds of lectures around the world and is the founder of the Colin Campbell Center for Nutritional Studies and the online plant-based nutritional certificate powered by eCornell. You didn't come to hear me talk, so it's with a great deal of pleasure and humility that I introduce the man who changed the world, Dr. Colin Campbell. It's all yours.
Thank you so much, John, for that's the first third of my lecture. So, I want to follow up on those very kind remarks that John just made. I want to, by way of introduction, though, actually tell a little bit about a personal experience we had today. That's my wife, Karen, and I. By the way, she's the one who was getting annoyed at me for complaining about some of my colleagues in science herself, and she said, "Why don't you go out and write a book for the public?" That was the China Study. So she's the one who really made me get out of behind the lab bench to do what we did. So anyhow, here we go. We today had an opportunity a really marvelous opportunity to visit the clinic of Janine and John Beard. I have to say that this is the future of nutrition. It really is the future of nutrition. They very kindly asked Karen and I to sit in a couple of their consults with new patients, and it was just brilliant, absolutely brilliant, making people well, and people acknowledging it and saying that's what really happened to them. So that's a big part of the story as far as I'm concerned. Let me go here to the next thing. So my take on all this business about being sick and what we can do about it is basically trying to understand this concept called nutrition. It's a science, it really is, even though it's not taught in any medical school in the United States. Nutrition, I define nutrition as the biological expression of food. We eat food, the food is digested, it's absorbed, it does this and that, metabolized. It's all the business that goes on in our body. That is the definition of nutrition that is really so little known, but so elegant, absolutely so elegant once we understand what nutrition does. It's been kind of left out of the picture, I must say. Now, to get into this, I have seen over the years an enormous amount of activity and complexity, all kinds of biological events, biochemistry, physiological, politics, I might say, policy and so forth. I've seen all kinds of things, and so there's a lot of details here that one cannot cover even in 100 lectures. So I'm going to do the best I can to try to pick out a few key things. With all that complexity I've learned about over the years, there's a couple of ideas I want to share with you tonight that I think are kind of at the top of the list. One has to do with our reverence, almost, if I can use that word, our reverence for protein. And by that I mean animal-based protein. The other is our sort of notion that somehow we get medicine by taking one chemical at a time to treat our illnesses. But let's start off here on this question concerning the protein issue. Here's a graph of the World Bank, as you can see here, that shows the relationship between amount of animal protein consumed as a function of national income. Boy, that's about as tight a link as you could possibly see. When a country gets more, or a society, when a society gets more money, one of the first things they want to do is eat good food, and for them, around the world, is to get an opportunity to eat animal protein, which is considered to be high quality compared to plant protein, which is low quality. You can see that graph there is recently published. That tells a lot. So we tend to eat basically what makes money for others, and we in fact pay for it. So this idea of animal protein being high quality, that's the concept that I also was involved in my graduate work at Cornell University, the animal protein is high quality, and I'll come back to that in a moment. But now we really know in science, some of the difficulties of that belief system, and it needs to be challenged. But and so the word's kind of getting out there behind the scenes, unfortunately, not necessarily with the public. But if you look on the internet now, these days, you just go and Google this question, if you will. What you tend to see of the articles that are there about protein, if there's any about animal protein, it's all about how are we going to meet the needs of the future. Because the poorer countries of the world are now making more money, and the first thing they want to do is get access to animal protein, so-called high-quality protein. So the question really becomes, how do we meet the demand for more? We're already having a heck of a time. We have had for some time with this notion that animal protein is so prominent, if you will. But this is the question that we seem to, you can look on the web yourself, and you can see the focus of the questions for the future is how do we meet the demand? So to make this story then even broader and bigger, I've listed here some items that we talk about these days, some problem areas we have. I've just picked just a handful on both sides. I've divided these problems we tend to have into environmental problems and human health problems. That's one way to do it. But in any case, we've got lots of environmental problems. You can see soil loss, climate warming, deep water loss, and so forth and so on. Each of those tend to command their own audience, and they tend to command their own researchers and policymakers, if you will. So you have these isolated communities, in a sense, working on their work. That's fair enough. That's fair enough. We need intensive work for each of these. Then on the other side, human health, you can see there. Healthcare costs are through the roof, okay? And we depend a great deal on the use of foreign chemicals. We call them drugs, prescription drugs. We use the most prescription drugs of any country in the world per capita. We've got side effects, we've got all sorts of things. Even now, actually, the United States is in last place among Western countries in life expectancy. That's a statistic I doubt any of you have really heard very much about, but we're not doing well, even in life expectancy, okay? So I want to just point out here something that when we get involved in this kind of activity in the research community or in the policy community or in the public, we tend to think of each one of these items as a separate entity to be resolved. And so we focus on it. We have workers around it. I'm going to suggest, and so because of that, we tend to think there are independent causes of each of these items. There's a bunch more. You can figure it, you can name some yourself, I'm sure. But we tend to assume they're independent causes. I'm going to suggest that's the wrong kind of thinking. I'm going to suggest there's one comprehensive cause. One comprehensive cause. It's basically the nutrition connection. But we don't teach that in medical schools, of course. The public knows so little about nutrition, it's terribly confusing. But that is the umbrella that touches every single one of these items here, and really, quite frankly, in a major way. So let's get back to some of the data, some of the arguments that I have for raising this question of animal protein consumption. There is a problem with the focus that we give to animal protein. As John already mentioned, that I was raised on a farm, and so I know about the farm, I know about food production, that sort of thing, if you will. In 1956, my dad sold the cows, and 3 months later, I was in graduate school. And so I want to point out that because I was really immersed in this idea about the importance of animal protein, if you will, and modern agriculture, just like everyone else. I'm no different. It's something you just don't even question, to be honest about it. So our activity was harvesting for cow feeds and in order to get the milk and therefore get more protein. That was it. Then when I went away to Cornell University, I did my doctoral dissertation, focused on this question of figuring out how do we consume more animal protein. That's what my PhD thesis was about, working with my professors at Cornell. Animal protein is so important, we got to find some new ways to actually get that ball rolling, essentially. And then shortly thereafter, when I took my first academic position at Virginia Tech University, I was asked to coordinate a nationwide program of feeding malnourished children in the Philippines. This was actually funded by the U.S. State Department at the time, and so that's what we were to do. I just like all of my colleagues, you know, the malnourished children issue is a big issue in poor countries, obviously. I was very deeply touched by that when I was involved in that activity, and I never can forget those children I saw. But the idea was that the children who were malnourished and starving, yes, they need more food. Obviously, we have to deal with that question first. But basically, the general consensus was these children were malnourished and sick and dying because they weren't getting enough protein, especially high-quality protein, meaning animal protein. So that was, again, that was consistent with what I did on the farm, with what I was doing in graduate school, and then on at this. It's just nothing terribly new and different, really. But then I happened to have seen, I've got here a problem with I happen to have seen some evidence, thanks to some of my medical colleagues too, some evidence that the few children that consume the most protein, they had a higher risk for liver cancer. Now, liver cancer is a serious cancer. It's a number 5 cause of death in the entire world. Now, liver cancer is basically caused by a virus, hepatitis B virus, okay? So I saw this evidence, it was just an impression. I had no proof of it. I thought that's what I was seeing, and my colleagues sort of suggested it might be true. So I had to deal with this question. How are we going to promote the consumption of more protein when in fact the children, with the evidence of the few children consuming more animal protein, they got more liver cancer? So that was the genesis. That was essentially the genesis of my career. It suggested there's something wrong here. Animal protein has some kind of association with liver cancer. It doesn't seem to make a lot of sense. In a larger context, of course, to say that, even to suggest the possibility that the most revered of all nutrients, protein, animal protein, was causing the most feared of all diseases. You can imagine the sparks that flew around that idea. It just simply wasn't part of the conversation. So I came home and to my laboratory at Virginia Tech with a lot of students that we had at the time, and we organized a project that was funded by the National Institutes of Health, which lasted then essentially that particular grant and others for about 40 years. So I had adequate support, good support, financial support to continue to do this work for at least 40 years. And it was your taxpayers, the taxpayers' money doing it. So I wanted to show now one item here that, one graph. I've got hundreds of graphs of showing various subject things as we went forward trying to learn. I wanted to know what is it true that animal protein causes cancer? So we looked at it in various and sundry ways. I finally came to the view, even though I wasn't particularly believing that that was likely to be true, nonetheless, we've had one particular chart that really just convinced me once and for all, I guess, it's just about. Basically, in the first 12 weeks in experimental rats, we gave them 2 different levels of protein, 2 levels of protein. This followed an earlier study in India by colleagues there who showed that rats fed 20% protein, that's 20% of calories, exposed to a carcinogen that causes liver cancer. The rats fed 20% protein, they got more cancer. The rats that did not much less. So I wanted to essentially repeat that study to see if that's really true. So here in the first 12 weeks, I don't have a pointer here. John, you know who has a pointer? I'd like to have a pointer if I could. Forgot about that little item, but in any case, let's do it this way here. Can you see that? Yeah, you can. I'll work from here. Okay. So in any case, first 12 weeks, 2 groups of rats. They were both exposed to a carcinogen that causes liver cancer. The animals fed 20% protein, which is the usual recommended levels, called it high levels, if you will. The cancer was growing well in those first 12 weeks. The animals fed the 5%. They did not grow. You can see here at the bottom. Okay. Then one of the little tricks that we did to see, to kind of test this idea, whether or not this might be true, was to ask the question, what happens if we change the diet going forward during this first 12 weeks? And so we did that. fed them 20% for the first 3 weeks, the cancers are growing well. Switch it to 5%, the cancer turned off, turned on, turned off. That was really quite remarkable because, I mean, just to think about it, cancer is now growing, okay? It's an experiment on animals, obviously, but the cancers are growing. And just simply changing the intake of animal protein made a huge difference. And it did it. You could see these effects easily within 3 weeks in this case. We subsequently learned you could see these differences in a week or so. So here's a really prominent effect that was coming on the scene. In a larger context, this idea of believing that, or demonstrating, I should say, demonstrating that we could take a nutrient, in this case protein, we could adjust it up and down, and we could control whether or not cancer occurred. It's that simple. That had huge implications, because what it tended to show, that cancer is largely a result of inadequate or improper nutrition, if you will. Today, then, until today, the Cancer Institute will argue, you can see this on the web if you want to go to the websites and look it up. The cancer industry itself, and the research that go along with it, they will say right up front, cancer is a genetic disease. In other words, cancer occurs or doesn't occur primarily because of our genetic predisposition. You know, it's in the family, if you've heard that term. When in reality, what we were showing here was that no, yes, that the genes, after they're initiated, if you will, to give cancer, we can control whether or not that cancer grows just by the nutrition it gets. In this case, it's of course with respect to protein, or animal protein actually. The animal protein we were using here to turn that cancer on, of all things, is one of the highest quality proteins. Milk protein, cow's milk protein. The protein that we were using to turn that on is casein. Many of you may know of casein, of course. And in any case, that brought me back home again. You know, it's the days on the farm when I was milking cows. It brought me back to my own doctoral dissertation, where we were basically arguing, myself and my professors were arguing that, you know, the more protein, the better off we're going to be. So this was a point in time when this and a couple other things that really got me to say, you know, what I have tended to believe and everybody else believed might be wrong. It's really quite a shocker to see this kind of information. So then from there on, I wanted to know still more. How true is this? How can we believe this? And you know, what's the mechanism? How does it operate, if you will? So we did some other things going out along that line. And in terms of looking for the mechanism, I should tell you too, that speaking in this case is more meaningful perhaps for scientists than the public, but I was in two professions at the time as far as biomedical research was concerned. I was in the profession of nutritional science, and I was in the profession of pharmacological science. In fact, in those days, I was on the pharmacological track. And I'll tell you what that means in just a moment. So I was more focused on the idea of, okay, if you see something like this and you don't believe it, you know, what's the mechanism? What is the mechanism? That's the way pharmacology works. Drugs are administered in order to attack a specific mechanism. So we look for a mechanism. Now this chart here, what I'm showing is, this is what we did in research, those of us in cancer research. As we studied questions about cancer and how it evolves and what's kind of nutrients involved and that sort of thing, we divide cancer up into three. This is purely a schematic kind of thing, but we divide the process into 3 stages. The first stage is called initiation. That's when the cancer forms. That's when a so-called mutation occurs, where the gene is being disrupted. So that's the first stage of initiation. The second stage is if the initiation succeeds, that is to say, if a new cancer cell forms at some point in time, at that point in time now some new cells have this cancer cell, if you will, or at least has the genetic potential to grow to cancer. At that point in time the cell divides. Finally it grows, becomes almost visible, if you will. That's the stage of promotion. That's the stage during which we were finding out that protein, turn it on and turn it off, could really have a major effect. So promotion, you'll see the arrow is going one direction to the right. And then in the third stage, at least to bring it back to the human experience, in the third stage, a person discovers they got a problem, let's say, and they're diagnosed with cancer. By that time, it's getting along, and that's the time, theoretically, when a cancer is usually in a tissue here, migrates here. We call it metastasis. And so that's when you go from a stage 1, stage 2 to stage 3 or stage 4. In any case, that's the scheme that we operated with. So the first order of the day was to look for the mechanism to account for this effect in the first stage. I put them in white, you can't see them all, but the story I want to tell is bigger than this. But in any case, we learned that the high protein diet increased the rate at which the chemical carcinogen gets into the cell. Oh, we got it. That's the mechanism. That's the mechanism. And the way we think in pharmacological concepts, let's see if we can find a drug someplace to block that. And then we can use the drug, and then we can use the drug, if you will, to block that, keep that carcinogen from getting into the cell. Doesn't that make sense? That's really that was the first thing we saw. And then if we can have a drug and we can take it every day, if you will, then of course we can go on and eat the animal protein and not worry about it. So that's the kind of concept that arises from a pharmacological perspective. Our immune system comes into play and produces some cells called natural killer cells. You know, it's an obvious name, but today it's called T cells. You may have heard about with respect to the COVID-19 discussion that's going on now, because the researchers are feverishly working hard to try to figure out some way to increase our activity of T cells in our body so we can resist virus problems like the pandemic, the coronavirus, if you will. So we got 8 mechanisms turned on, 2 mechanisms, good ones, or default mechanisms, if you will, turned off. All 10, they end up doing the same thing. They all increase cancer. And here's a remarkable part of the story. I find this is the most exciting thing that I've learned in all the years I've been in research. These mechanisms are turned on in an instant. As a matter of, when I say mechanism, I'm talking about either a substance is a metabolite of protein or a metabolite of this, or it's an activity, an enzyme activity, or it's a rate of transfer across the membrane, whatever. These are all called so-called mechanisms. And what turns out is that all these mechanisms, just like that, just in an instant, can change. It's an extremely dynamic system. Now, we just did 10. In this day and time, I'm sure you could probably, if we went back and did it again, probably find another 100, another 1,000, another 100,000. Here's the notion, and this really questions what the whole concept of nutrition is all about. Okay? We tend to think of nutrition in one nutrient at a time, calls it this, that, or something else, one disease at a time. And then we turn around and think of an antidote, one drug at a time. See this one. We tend to focus on these details, when in reality, in this case here, when we consume food, in this case protein, high animal protein, it starts causing problems of one kind or another. It's causing a whole host of problems. And here's the really impressive thing about the story that I think is germane. These nutrients are all changing together to do whatever they do when we give them the wrong nutrition in the first place. When something goes wrong, it doesn't go wrong because of one thing, or 10 things, or 100 things. They all work together. It's almost asking the question, who's directing this traffic? You know, how can we end up thinking the best of science is focused on one thing and studying in great detail, when in reality, nature has it that all this stuff is just working together. All just working together, all the time. And over 30 trillion cells in our body. Whether it has to do with cancer, a different kind of cancer, heart disease, whatever the case may be. I'll come back to this point a little bit later on, because this is a really essential point as to why we are so confused about nutrition, to be honest about it. So in any case, to make a long story short, we couldn't decide which mechanism mattered. So I kind of dropped my specialty in pharmacology in those years after 10, 12 years and turned my attention to the other area that I was interested in, and that was nutrition. So I had to look at how pharmacology interpretation works, and then had to look at how nutrition works. Nutrition beats pharmacology any day. So let's go to another stage. So what those studies did was something we all regard as kind of almost sacred in science. If we see a cause and effect relationship, especially when it's troublesome, we can't quite believe it, right? The first thing we have to do is see if it's biologically plausible. Can we explain how it works? Well, I'm showing here, we can. We can explain how the protein does. When we consume animal protein, everything goes wrong. Everything goes wrong. It may affect some various systemic cancers, it can affect chronic kidney disease, it can affect heart disease of various kinds. And that's a concept of nutrition that is, I'm really trying to get better known, if you will. That it's something, all we need to do is, the whole question is simple. Eat the right foods, it's got the right nutrients, period, end of story. Unfortunately, we have such a reverence for protein, animal protein. We all, for hundreds of years at least, have wanted to get some of that good protein, animal protein, because it's so-called high quality. When we have that in our minds, whether we do it subconsciously or consciously, beside the point, it drives us to assume that we should be eating animals to get that good protein. At least protein was discovered way back in the 1800s, but it's a driving force with our sort of believing that the most important thing we can do with our lives, essentially, is make sure we get some protein of the animal protein kind. So that demonstration there really showed to me, there's no mistake about it. Animal protein causes cancer in that model. Now one can argue, that's just a rat. You know, what does it have to do with humans? That's just liver cancer. What it has to do with other cancers and so forth. But it was a demonstration of a fundamental principle. So here's another way to look at the protein question. And in this case here, I'm drawing on the research of others that have been done over the years. And I just had an opportunity to go back, and I think maybe 10 years ago or so, to go back and see if I could find some data of a different kind on a question concerning animal protein. I wanted to see if anyone had graphed the relationship of animal protein consumption, right, with various diseases. And the researchers had. The earliest paper I found was 1959. A gentleman I knew at the time I was a student myself. But so I pulled these graphs out. They show something really remarkable. Here's a relationship between kidney cancer and animal protein for different countries. So this researcher went out and collected information on how much protein is consumed in all these different countries, how much kidney cancer they get. See that line there? That researcher did not, at the time, draw that regression line. I put it on there just simply, in a formal way, determine what it was. You can see the straight line relationship coming down. It sort of suggests, in theory at least, as soon as you start putting in some animal protein in the diet, then you're raising the risk for kidney cancer. And that's impressive. That's quite an impressive line. So we did it for kidney cancer. Here's one for heart disease and animal protein intake. This man here, this research was done in 1959, as I said. In that particular case, heart disease, the amount of heart disease we see in a country is a function of how much animal protein we consume. Now, one of the things that animal protein does, and we've known this more than we've known this about 125 years. Namely, animal protein is what causes cholesterol in your blood to go up, which in turn relates to heart disease. It's not saturated fat. It's not even total fat for that matter. It's the animal protein. It's our belief in the animal protein concept. And so when we consume animal protein in this particular case, we're consuming more saturated fat, if you will. And so we get really blamed the saturated fat, and that's what we've done over the years, instead of the animal protein itself. Just stop eating animal protein, and then you get rid of some, you consume less saturated fat. So here's another one. Here's prostate cancer. This is done in the 1980s. Again, a bunch of different countries, okay? This is the risk of prostate cancer. as a function of non-fat milk. Okay, non-fat milk, you know it, it's skim milk we call it, if you will. Non-fat milk. Non-fat milk, as the definition says, it doesn't have any fat, and it really doesn't have any sugar in it either much. The only other substance it has in the milk, by way of energy content at least, is protein. So non-fat milk is like a beverage, an animal protein beverage is really what it is. But they called it non-fat milk, and then focus on non-fat milk. And so we had some discussions going around and around about that for a few years. What is non-fat milk? Why is it turning on prostate cancer? That's an impressive relationship. And there's other evidence to show that prostate cancer, in fact, is a function of dairy consumption. And the principal agent there that has to do with that is the protein content in the dairy. Here's one for breast cancer and saturated fat. And I know I'm probably going beyond your understanding of science to some extent, but what I want to show here is that each of these plots done in years past, some other nutrient was generally blamed for the increase in those diseases other than animal protein. In reality, those 4 charts so far, all 4 of them are representations of consuming more animal protein-based food, period. And along the way, we get it from milk, or we get it from, we blame it on saturated fat and so forth. And when that's not really the question, it's our belief in animal protein. Here's one for cholesterol intake and heart disease. Heart disease, in this case, the XY axis is different. So here's, for all these different countries, if you will, the higher the rate of cholesterol consumption, you all know that cholesterol is only in animal foods, I think. It's only in animal foods. And so the cholesterol is then blamed for causing heart disease. Therefore, we cut down cholesterol consumption. It's not the cholesterol. It's not the cholesterol that does that. When we're consuming cholesterol, only in animal foods, we're consuming animal protein. So once again, the cholesterol is a representation of animal protein. Look at that relationship there for breast cancer. Let's go to another. There's colon cancer and meat. These are different studies. And always the lines are always the same. They're always the same. Here's uterine cancer and total fat, which is a representation of animal protein too. So here's 7 charts. I know there's another 3 or 4 at least out there. I just haven't had a chance to go back and get them and put them in these screenshots. But each of these diseases are showing the same relationship. As soon as we put animal protein in the diet, the risk of those diseases going up just like that, straight line relationship. Most of them are coming right here near the so-called XY origin. In other words, the best way to avoid risk is no animal protein. It's that simple. I mean, this is so convincing, these charts here. They're so convincing no one will ever show the reverse, I can assure you. Nobody's going to be able to come along and sort of say, oh, these diseases will go down as we increase animal protein intake. That's not the way it works. This kind of representation here, plus the idea that protein causes all these mechanisms to work together, if you will, that combination of observational data on one hand, this is observational data, with the biochemical mechanisms on the other, that combination really puts a dent in our belief in animal protein from my perspective. There's no other way to get around it. Animal protein is basically toxic. It really is, and it comes in the form of creating the kind of diseases. But let me say this: when we consume animal protein, this is a really important point. I don't mean to say that animal protein all by itself causes these diseases. Not by any means. Yes, it does. But when we consume more animal protein or animal food, let's say, we decrease the consumption of plant food. So the plant, and so both of them work together. More animal food, lower plant food, result in the same effect. So these lines here are representations, not just of eating animal protein or animal protein-based foods. It's also eating less plant-based foods. I can hardly imagine any data that we have in science over the years more convincing of this effect, or any effect, than this set of data. On one hand, we're demonstrating the so-called plausibility of the animal protein effect. Yes, it does this work, but multiple mechanisms. But the second thing is, We can just see it when we compare countries and the amount of animal protein they consume. So that really got me on the kick of questioning animal protein, going back to the observations that I was seeing in the very beginning of my career, not believing it. This came as a result of actually disproving my own beliefs as well as those of others. And I'm really convinced that it is true. This last one here is plant protein. It doesn't do it. Plant protein doesn't work this way. Plant protein, when we're consuming more plant protein, that means more plant foods. We're consuming lots of so-called antioxidants and fibrous materials and so-called vitamins and this and that. So it turns out they're all just basically working together. It's not one thing at a time. In the interest of time, I'm kind of watching my time here. I'm going to skip over this a little bit here. Let me tell you what I was going to show in this slide here, with these next 3 slides. We tend to assume that animal protein is high quality, as I said. That's a representation of the fact that when we consume more protein, animal or plant, we consume more protein and more of it is retained. That's called high quality. What so happens, all the animal proteins are like each other. Meat, milk, eggs, and all the rest of it. The protein in those substances, more of it is retained in the body. That's said to be a good thing. We call it high biological value. That was done in 1924, quite 100 years ago or so. And so we have always ever since talked about high quality animal protein. That is false. Animal protein is not high quality. Because when we retain more of the protein in our bodies, we not only get faster growth rate, which sounds like okay, but we get more heart disease. We get more cancer. We get more of this and that and everything else. So the concept of high animal protein by high quality is false. It is simply false. But it's an idea that you may not have seen it or heard too much about it, but we almost know that without subconsciously. All we know is if you hear somebody say, I need my protein, they're usually meaning, either directly or indirectly, without even knowing, they're usually meaning, I need more protein from animal foods. That's really false. We shouldn't do that. And let me go, in the interest of time, I'm going to go through this. Yeah, because the more we retain of that protein and the so-called high quality, all these things here, these are all scientific mechanisms, if you will. When we consume more animal protein, we get more cancer. That's irrefutable. We get more heart disease. Cholesterol goes up, and the cholesterol is related to heart disease. We get more blood sugar and the so-called A1C, which are a couple of indicators of diabetes. So, and more. I can show still more. So the so-called higher quality proteins means more diseases and more deaths. And these are diseases that actually represent by far and away the majority of the deaths that we incur in our society. By the way, plant proteins don't do this. We did this study many years ago. We tried soy and wheat protein to see if it could turn on cancer like the animal protein. It didn't do it. Even when it fed the soy protein up to a level of 20%, it still didn't do it. So animal protein and plant protein are like this, worlds apart. Here's animal protein, here's plant protein, and if we're going to eat food just because we're going to get this protein or that protein, we're also consuming a lot of other things along with it. And they all work together. They all work together. I think it's almost time in science, and if we could convey this to the public as well, the nutritional effect is so powerful. It is so powerful. It's so broad. So it reaches out. It's broad-reaching, if you can say, so comprehensive that it relates not just to this disease, that disease. It represents virtually all these diseases that actually kill 75 to 80% of us before our time. That's how big this effect is, because we don't seem to realize that we're, in fact, consuming the wrong food and the nutrition it produces. Animal protein has been part of our psyche, of our subconsciousness forever. I think many of you know, probably many of you are sitting there just like I would have sat there too years ago, believing animal protein is so great. I call it our belief system in animal protein, whether we say it or not, or whether we really know it or not, I can explain it. I call it the interest in getting animal protein in our system is the main driver of dietary change in our societies. Because as soon as the country or society gets enough money, one of the first things they want to do is to get this good food that the U.S. uses. I heard this a number of times in China. My colleagues even set the recommendation at the national level to consume more animal protein because they wanted to get there, because in those days when I first heard from my colleagues, they were interested in getting more protein because it was what civilized countries do, and they tend to win Olympics, and then China wanted to have superior athletes, so they really worked hard to make their athletes get more animal protein, so when the Olympics time came along, they could compete. So questioning this idea that protein is as important as what has been said to be, has ruined more professional careers than I can almost imagine. It usually goes unsung. It's not told. It's not told because so pervasive is this belief in animal protein. If somebody comes along and tries to question it, they can get in trouble. I know from personal experience when you start talking this way. So given that idea there about protein at least being, animal protein being bad, and plant protein being okay, and all kinds of other complexities, I've reduced my sense of this complexity down to a couple of simple thoughts. And then we don't get lost in the weeds. Namely, the simplest recommendations that I can sort of say are related to really solid science, and at the same time are sufficiently simple for the public to use, are these. Don't eat animal foods, number one. Don't eat animal foods. There's no need for them. Plant proteins, vegetables, fruits, grains, they have all the protein we need. We don't need that much to begin with. It's only like somewhere 6, 7, 8% at the most. And so we're at the level of around 17, 18% right now, with about 75% of it are coming from animal sources. So that's recommendation number one. If we just remembered that, we can forget all the rest of the details insofar as animal food is concerned. Just don't eat it. And then a lot of the detailed recommendations can be pushed to the side. The second recommendation that I like is this one here. When we're consuming plant food, try to consume it as much as possible in a whole food form. And it's okay if you cook it. The cooking really has nothing to do with it. And so it's okay if you dice and slice the plants up and that sort of thing. It has nothing to do with it. I'm not talking about that. I'm just talking about when you eat the plant, the vegetables, fruits, whatever, eat the whole thing more or less at the same time, because Mother Nature knows what to do with it. And those thousands, hundreds of thousands of nutrients and those substances in plants, they go to their stomach, and that's another whole discussion. She knows how to assemble that complexity together. Everything working in unison. It's really it's amazing. And so you tend to see that those who have the highest risk for heart disease, oftentimes have the highest risk for cancer, and oftentimes even diabetes. So this is an all-embracive, comprehensive kind of recognition of nutrition in a sense. It is so powerful. If we do that, we can reduce total deaths, premature deaths I should say. We can reduce premature deaths by easily 75 to 80%. By premature deaths I'm talking about people who died before their time. And so if we just change our diet, it would have an amazing effect if we just, now, on what we can do for ourselves. I want to just spend like 2 or 3 slides on here telling you about whole food. Because whole food, it's got whole plant food, it's obviously got all the good things, it's got fiber and vitamins and this and that. So how do I end up saying that? Let's have a look at this. There's something really significant here. By the way, here's a thought that we don't often talk about. When we consume more animal food, we consume less plant foods. That's a seesaw thing. That's consistent across all societies. If we have more of the energy coming from animal foods, we have less from plant foods. Those are the two that contribute to our caloric intake. So this brings it to, now on this, I'm sorry about this here. This sounds terribly technical and all that sort of stuff, but let's see if I can make a little sense of it. How many of you are sufficiently in health or whatever, have you heard of the Krebs cycle? Anybody? Oh, quite a number here. Okay. So this is the beginning. This is so-called metabolism, where when something goes into our cells, it's broken down, so we can get the energy out of it and use it. If you start at the top, the energy, we get the energy from the sun. We all do. We get the energy from the sun. It comes into the plant. It's a process called photosynthesis. And so the plant converts the solar energy into chemical bond energy, okay? First thought the plant is making some sugar packed with energy. And then that energy, when we consume it, it breaks down step by step by step by step. And all the steps going along there are, when we eat the plants, it takes out a little bit of energy along the way. So that's the first stage called glycolysis. We won't get into that detail. And finally, the Krebs cycle. The Krebs cycle is the stage where we're getting a lot of energy for the food we're eating. So this is really an energy extraction process, if you will. So that's the basics. I taught this myself for about 8 years of biochemistry majors many years ago, and at that time, in the early 60s, these reactions were sort of getting to be known. It sounded complicated enough, but that was really quite simple, because about 10, 12 years later, something like that, we had this. It wasn't a simple set of reactions. We were feeling smart. We could learn each of these things, and we could do this and that about it, but then it got this. Now, this is 100 times more complex. It's beyond our comprehension. So what does that mean? You say, what in the world am I telling you that for? This is going on in every cell in our 30 trillion cells in our body. Each cell is like a universe. So there's an enormous amount of reactivities going on, essentially represented by this complexity, if you will. Now, okay, just think about that for a moment. All this complexity, and far more. If we could find which one of those reactions is responsible for causing this disease, like I said before, it turns out there's not a single one. Most of the time, there's not a single one. But that's the drug precept. That is what the drug industry rests its case on. They call it the best of science. We're going to find the key reaction, and then we're going to find a drug for it. We're going to block that. It doesn't work. It doesn't work like people assume it does. It can have some short-term effects on occasion, but they have side effects. Okay? So that's the drug protocol. Trying to hit one reaction at a time. The food protocol or nutrition protocol, there's hundreds, thousands of nutrients, if you will, nutrient-like substances. The food thing, when we consume food, it somehow, Mother Nature addresses all these things at the same time. Truly amazing. That's the way nature works. Nature is just addressing all this at the same time, and it doesn't have much use for changing this nutrient or that nutrient or this drug or that drug. It's amazing. So the food protocol, we have multiple nutrients and no side effects. Third leading cause of death in the United States is side effects of drugs. The third leading cause. In some estimates, they say fourth leading cause. In some debate there about how you rank them. But in any case, drug side effects is a major cause of death in this country. Never hardly told. Because the CDC basically represents the domain of this area. They rank the 10 top leading causes of death, heart disease #1, cancer #2. They never have put in there side effects of drugs. Public doesn't know it. So just think of drugs. Then you come back to this point here. Why are we using drugs? We're using drugs because we're eating the wrong food. And we get sick. 80%, I don't know what the latest figures are, something like 80, 90% of people 80 years of old or age or older already have been diagnosed with a disease. Obesity, kidney disease, heart disease, diabetes, whatever. So the vast majority of people in our country are suffering from diseases that are all linked to the food we eat. But pretty good business for the other part of the country, for the other group in the country, because we have a lot more sickness. Now we got a tremendous opportunity to sell a lot more drugs. That's the way the system works. I know this is harsh to say that, but this is science, this is what the science shows. And I've shown this, there's no other way around it. We allow, for various and sundry reasons, for people to not hear what I'm saying on one hand, let them get sick, and then in the process, we got a drug for you. That is our system, I'm sad to say. And we can do it the other way around. Let's eat the right food. Let's eat the right food. Okay, let me go a little bit further here. So I want to just now give you an example of how we've gone wrong. Back to that chart I showed you before with the Krebs cycle. Okay, long about in the middle 1980s, we heard that, it became fairly common knowledge, the amount of cholesterol in our blood, presumably the amount we consume is not the same, but the amount of cholesterol in our blood, the higher the cholesterol in the blood, the more heart disease risk, right? You've all heard that. And so the question was, well, how do we reduce the cholesterol in the blood? If we can get that down, maybe we can reduce heart disease, right? Middle 80s, mid 80s, a lot of discussion about that. The whole country's told about it, right? So the question, we make some of our own cholesterol, a lot of it. The question was, if we can block our own synthesis of cholesterol, we can reduce heart disease. Pretty simple. We just need to find a drug. Get a drug to block the synthesis of cholesterol. And so some bright folks learned first that cholesterol is made in the body, and it starts out with a compound right here. It's called acetyl-CoA, a pretty critical junction. And that acetyl-CoA is a chemical, biochemical. It goes through a series of reactions, that dotted line there, we get serum cholesterol. So our bodies make cholesterol for good reason. Cholesterol serves a good purpose when our body's in control. We don't need to consume it, by the way, obviously, but it's making cholesterol. So the thought was, let's see, how can we get our cholesterol in our blood down? Here's what they finally learned about one reaction in that sequence here, one reaction, that maybe if they could block that reaction, remember the one mechanism, block that reaction, get a drug for it, they could block it, and therefore we can reduce heart disease. So they succeeded in finding a reaction that they could block. What about the LSA? The name of the compound was called statins. This is the birth of the statins. I don't know what the latest figures are, but I believe it's somewhere around $80 billion a year business. It's out of sight. And so, most people, later years, if they have any sense of their cholesterol a little high or whatever, they're just will take statins. Well, block statins and you get less heart disease. It turns out there have been multiple studies now done on this. There's a few studies show maybe a little effect. Some studies show no effect. All studies show side effects. The statins, in my view, have been almost a waste of time. And basically, relying on this very, very basic presumption, if we can go to one reaction, get one drug for it, all drugs have side effects, so we live with the side effects of statins, and we don't get much in return for it, if anything. In contrast, if we use a diet, whole food based diet, and my friends, you've heard of them, Dr. Calder Esselstyn, Dr. Dean Ornish, they, in somewhat more recent years, have taken people to give them the diet with people with heart disease, reverse the heart disease. It's a matter that it begins to occur within days. And there's no comparison between the ability of food to control heart disease compared with drugs. I mean, there's no comparison. One just gives us a lot of side effects. It doesn't do much good. That's the statins. The nutrition, on the other hand, takes care of that more. So that's the comparison. Here's one more that I find really interesting. This was. I hope I'm not getting into so much science here for some of you folks, but for me, the science is the basic stuff. It's not opinion. It's really what exists. That can't be refuted. Here's a paper that came out in 1981. It was at a time when, in my lab, we were working on, this kind of things about protein doing this, that, or something else. And I was getting in this inclination that just working on one protein at a time didn't make a lot of sense. This came out. Now, I wish I had a pointer here, but this is a little bit complicated. It's a so-called 3D graph. Look at over here, and this over here. See right here, this line of people here, non-smokers. This next group is the people smoking less than 30 years. And the upper one is that people smoking more than 30 years. And you can see the people smoking more than 30 years, they're the ones that get a lot more lung cancer. Well, we all sort of know that. Smoking's not good. We're going to get lung cancer. But look at that relationship. When they took the 30-year-old people, people smoking for 30 years, and they divided them in 4 different groups, and asked another question. They took it and they asked the question, what's your diet like? They answered the question. And they were asking particularly, how much spinach do you consume? How much greens and stuff like that? And they calculated how much carotene is being consumed. Now, carotene is pre-vitamin A, you may know. It's a good antioxidant. So, in any case, it found among the heavy smokers, the ones that had more carotene consumption, you can see here, see what that up there? They're very high risk of lung cancer and drop down. In other words, here's the story. Yes, smoking causes lung cancer, no question about that. Let's not smoke. But there's something else here involved. It's our consumption of green and leafy vegetables, measured as beta-carotene. This really caught my attention at the time. In fact, I got somewhat involved in it in various ways in those early days, because what this showed to me was that nutrition, done right, can even control the hazardous effects of bad chemicals, like the chemicals in smoke, for example. It's dramatic. That was also very much impressed a number of researchers in that time too. By gosh, you're telling me you could take smokers and if they eat more greens, they're going to get much less lung cancer? That's what it showed. So what they did, they immediately thought, hey, we got a way to control that. They organized another study to take the beta-carotene out and put in a pill. Let's take a bunch of smokers and give them beta-carotene in a pill. This is almost the birth of the vitamin supplement industry. So they want to sell beta-carotene. And then they did a study on that. It was a study of Norwegian and U.S. American researchers, and see that relationship with beta-carotene? That's really impressive. Smokers consuming more beta-carotene, much less risk of getting lung cancer. Okay, here's what they did. Here's the study I want to tell you about. What they wanted to test was, among the smokers, let's give them a pill with beta-carotene in it. That was the idea. Give them a pill. That solves everything really quickly. So they did the study, 29,000 male smokers, that's a lot. They were going to run the study for 8 years because you usually don't see much effect before 8 years. Such effect on lung cancer. So they did the study, working on it. At 5 years' time, they saw something. They had to stop the study. Here's what happened. People consuming more beta-carotene, lung cancer went down, 20%. Statistically significant, just in 5 years. That's a big effect, early on. So beta-carotene really works. In other words, foods that have beta-carotene in plants, only plants, they're able to repress lung cancer occurrence. That was okay. They showed that at 5 years. It's the same as the other study, nothing new here. More beta-carotene, less lung cancer. Then they checked people taking beta-carotene supplements. Do you know that people taking beta-carotene supplements, their cancers went up, statistically significant. That was a really dramatic finding for its day, because what that showed was that beta-carotene, a nutrient, a good nutrient, an antioxidant, it's in leafy vegetables. What that showed, if you take it out of the food and put it in a pill, and now people are supposed to take the supplements, and that'll do you good. That'll do you good. It can have the opposite effect. I happened to have, I don't know whether it was a fortunate or unfortunate position at the time of being called on to spend 3 years testifying in federal court hearings on these claims being made by manufacturers of supplements as to whether they worked or did not work. I took the position at that time, I was trying to keep an open mind. The beta-carotene, that supplements might work. But when I started looking at the data, I just couldn't believe that supplements really do not work, in a long-term context. In the short term, we can see some stuff, so on occasion, that, you can argue that kind of patch up here, patch up there, kind of thing. So there is room for, under certain circumstances maybe. But this has now been shown to be true for a lot of supplements. Either A, they don't work, or in quite a number of cases, you take the nutrient and put it in a pill like that, it's losing its context. It's not, in this massive effect, it doesn't have an opportunity to do that. It's just coming out all by itself. It's at loose ends. It doesn't do the same thing. It can have the exact opposite effect. So it kind of leads to this notion here, get your nutrition from whole foods. Eat the whole foods. You cannot substitute whole foods with supplements. That's not the way it works. A lot of people have been allowed themselves to believe that, partly because of the advertising, but they've allowed themselves to believe that, therefore they can keep on eating more food. That's a bad deal. That's not the way to get nutrition to work. This whole concept that my wife said, don't show this picture, but I find ways, I'm trying to find ways, how can we actually get in our head, understand what goes on inside the cell? Everything working together. I was walking, we were walking along a sidewalk one day, and I saw this. Can you see that? Yeah, these are all ants. They're somewhat like humans. They're all there doing their thing, all in a group, all doing their thing, whatever it is. I don't know what it is. About a week before that, they were about 50 yards down the sidewalk in another place. So they have to ask yourself the question, this is nature at work. Somehow she knows how to do things, and they kind of work together. We've kind of lost that, I think, too much of working together, each doing our thing. And the whole is greater than the sum of its parts in a way. You could show this kind of thing with birds flying. A swarm of birds, the black birds in the fall, they're flying around, they go like that. All of them just like together, just like that. Or schools of fish. How can they send signals to each other to do that? What are they doing? And so that's almost like what happens to nutrients inside of the cell. They just, does this work? Now I just want to show you a couple more things here. As I said, life expectancy in the U.S., this is 39 of the Western countries. Not the ones I talked about, more or less the ones I talked about before, but a bigger sample because it includes some others. This is life expectancy at 65 years. See, the U.S. is way down the line here. We think we have one of the best systems in the world. We don't, and it's getting worse. This is a rationale for drugs. And we are the #1 country in the world in use of drugs per capita. So we've allowed ourselves, and I can show you so much more, we've allowed ourselves to eat the wrong food, even when we should know better. We eat the wrong foods, we get sick. We get diagnosed with one of these serious diseases because somehow in our minds, unconsciously, oh, well, don't worry about it, they got some drug for that. That model does not work, really, not to our advantage. We're on the wrong side of the street on that one. And by the way, we use a lot of drugs, as you probably know. We're the only country in the world. New Zealand was doing this a bit too, but in interviewing with someone in New Zealand, they're changing this. The U.S. is the only country in the world that allows advertising of drugs on TV. So a lot of people come to believe in drugs, use them helter-skelter. They just, whether they're told by a doctor or not, they buy this or that. And Janine was showing us some today that people come to her center and they got a bag full of drugs or something like that, or a pocket full of drugs. Not drugs, supplements. As I say, supplements can have a place when they're very carefully used to generate some change, if you will. But anyhow, we've taken the past to eat the wrong food, we get sick, so then we turn our attention to using drugs. #3 cause of death. Now, if I may, I want to summarize something here. This is something about diet, health, and the environment. Here's the big story of the day. Many of you may know that. Nutrition is not only to make us well if we know how to do it. It tells us, too, what kind of food we should consume, obviously. We eat the wrong kind of food. That is a chief cause of environmental problems. whatever it may be, climate change, deep water, loss of deep water in the soil, all those things I showed you in the beginning, environmental things, they're all related to, first and foremost, by far, to the food we eat. And to be more specific, environmental problems have occurred because we consume a very high level of livestock, meat, milk, and eggs to get that good protein. That's why I want to concentrate, that's why I want to dwell on this topic of animal protein. Do we need animal protein like a lot of people believe? No, we don't. And if we take that away from our psyche, we don't need to eat animal foods for any reason. Plants have all the protein we need and more. So just the fact of raising livestock and using 6 to 10 times as much acreage to get the same so-called nutrition allows us to rip down forests and plow fields and lose soil to the Gulf of Mexico. Well, all these things in the environment that we're now seeing really are now being worked out by specific groups very clearly to show the data. If we just change our diet, we'd reduce healthcare costs by a bunch. We'd live longer. It's so simple. And we wouldn't be doing the things to our environment that we do. It's a grand, sort of a grand scheme of things that the so-called whole food, plant-based, and this is just kind of summary here, what I'm showing you here. Nutrition is biological expression, okay, and then we tend to assume that these effects, all the nutrient effects, that nutrition has an effect on this disease or this organ or whatever, or this, we assume that nutrition is operated by a handful of individual nutrients, each doing their thing. That's wrong. That's wrong. And really, nutrition works not by one by one by one. It's a whole lot of them working together. And so it begs the question, let me show you the next couple of things here, that when we're using nutrition to get the benefit of all those nutrients, they all work in unison in the cell. Amazing idea, really great idea. On the other hand, if we assume that they're still working one by one, we develop a drug because we want to wipe out the disease that we get from eating that one nutrient. So we've got two pathways, sort of philosophically or if you will. On the one hand, all these nutrients and nutrition are all working together. It's an image of nature. It is a picture of actually what nature is. She knows what to do. We eat the right food, let her choose what she wants among these millions of different combinations and put them together and prevent disease across the board, for the chronic diseases at least. When they work alone, if we assume that, and that's what we've assumed. My trade, my business, we have done the same thing. We work on one nutrient at a time, think we're going to learn this, that, and something else. And in reality, that's not the way to work it. When we work on one thing at a time, one mechanism, if you will, causes enormous amounts of confusion. And this is why so many people don't understand nutrition. So much confusion out there. You know yourself. You can, if you get an idea in your head, you heard this, you believe that or something else, just go around and ask how many other people believe the same thing. Someone will tell you, no, it's not right, or they'll tell you it's the opposite. So the confusion is obvious, and obviously it comes from our belief in choosing one thing at a time, not realizing it will work together. We choose one thing at a time because we're interested in, I guess, in getting sick and using drugs. When we look at one thing at a time, one nutrient, one disease, having one drug, if you will, if we can take that idea and we can surround it with intellectual property protection, that means protect the idea for business purposes, that is the drug industry. That's it. The drug industry is a means by which we can use individual chemicals, presumably, to make us well. And so that's a for-profit thing. Aristotle, ancient Greek philosopher, basically said many, many years ago, 2,500 years ago, the whole is greater than the sum of its parts. And that's what I'm talking about, the same thing. We just forgot what he said. This works in so many levels, whether we're talking about stuff going inside the body, or inside the cell, or inside the whole food production system, or whether it's politically. Wouldn't it be nice if we thought politically these days to work together rather than, just one mine's right, you're wrong kind of thing. We somehow got to come back to something sensible. So one arm is food, the other arm is drugs. Drugs make money, let's face it. Food doesn't make any money. Tell people how to get well just by eating the right food. That's quite a loss of profit for the other side of the equation. So I end up saying holistic nutrition. Multiple nutrients, mechanism of diseases. There's my general recommendation. Whole food, plant-based. I'm the one that coined the term plant-based back in the late 1970s. I was on a government committee at that time whose responsibility was to determine which research gets funded in cancer research and which ones don't. And my colleagues, there were about 13, 14 of us on that committee, we were the ones making the decisions on who gets the funding for research and who doesn't. As I said, my colleagues were oncologists and biochemists and pathologists and so forth, and there was some interest in rising at that time with applications coming into occasional researcher wanting to study nutrition and cancer. I was the only nutritionist or nutritional biochemist on the committee, so they asked me to spend some time telling them what nutrition is, and I did just in 78, 79. I did not want to use the word vegetarian, to be honest about it, because I didn't come to this party first believing in vegetarianism. As valuable as it may be, that it is, that's not the issue. I wanted to use something different, to draw the discussion back to something that sounded more scientific, because for me, that's what really drives the argument. So I came up with this plant-based at the time. I didn't know where it was going to go anyplace, but that was in 78, 79. 3 or 4 years later, I had experience in determining which kind of nutrients might be used in supplements, which made clear to me we should eat whole food. So I then put the word whole food plant-based together, and I didn't think that would go anyplace. Well, it turns out now in the last 10 years or so, that concept, whole food plant-based, which is different from veganism, by the way, and vegetarianism in significant ways. It is really addressing, I think, I hope people understand this. It's based on facts. It's based on real science that cannot be refuted. It is the future. It is the future. And I'm gratified to actually see the number of people who are beginning to grasp that idea and using it. What Janine and John are doing with their center here, and some other folks are doing it elsewhere, is very gratifying, because they look at a person, they can look at various and sundry complaints and issues and symptoms they may have, size it up, and then give them advice. That, in the vast majority of cases, they can see healthy results in very quick order. That's the future. That's the future of nutrition. Somehow we have to learn how to communicate this idea. The vast number of people in our country, unfortunately, don't get to hear this. They hear the word whole food plant-based maybe, but I don't think the vast majority of people are really grasping how important this idea is of nutrition controlling health. It's just like second to none. And I'm sure it's going to win the day eventually. So I'm going to stop here. I see my friend. But medicine is just exactly the opposite. We want one disease, one target of drugs. Okay, there you have it. I don't have much more time. I have to see my coach standing over here. Well, that's okay. I'll finish the one chart here. So reductionist medicine is based on the other concept. It's using one thing at a time. Look at this disease. What you learned about this disease doesn't apply to this disease. That's wrong. It's this mechanism, not that mechanism. That's also wrong. We have forgotten unity. We have forgotten what nature really is. She's had a few millions or zillions or whatever. She had to work things out. It's amazing. The China study came out some years ago now. It went with my son, who's a physician himself now. And he actually recently published a paper on a gentleman who had chronic kidney disease, 69 years old. He switched to me just on the verge of going to dialysis, advanced. And so he put him on a whole food plant-based diet. He did a really good job, following him, making sure he ate the right thing. 4 months later, the man said he felt like a 20-year-old, gone. And that was published. That's chronic kidney disease. We've seen it in heart disease in spades. We've seen it in diabetes. And so all these diseases, all of a sudden, I think we're coming to a vortex in our thinking maybe, where the causes of all these different diseases, it's not so complicated. We don't need to think about this, the drug for this and this and this, and then worry about whether or not it causes something over here. Just keep it simple. Just use a whole food-based diet, and you kind of got it licked. I published a book in 2013, I guess, where I'm dealing with this topic of the wholesomeness of nutrition, not the single nutrient kind of thing. And this is the most recent one, back just 2 years ago. I wrote with my grandson. He was the writer, with the author, if you will, great writer. Here I'm trying to outline the mistakes we've made. I'm sitting discussing the mistakes we've made that become part of our conversation, not knowing it, and have been terribly misleading. And so the idea of being able to sell this story on nutrition to the general population is difficult, as long as we're having to labor under some misunderstandings and misstatements of so-called fact that are no longer in vogue. So I'm going to leave you there. We have an online course if you're interested. The online course is, I'll just tell you the URL is nutritionstudies.org. It's one at Cornell University. We've had at least 20,000 graduates, and we're kind of excited about it, extending it. We got more to tell. Another whole line of courses just on this idea about protein and wholesomeness. So you've been a very kind audience. Listen to all this. I'm sorry, I hope it didn't race through some of these explanations. The biggest struggle I have when I give lectures on this on a broader scale is trying to figure out how in the world can I tell in 1 hour all the main points I can't even get close to. So what I told you here is worth about 50 or 60 lectures, to believe it or not, to really get a grasp of this. But I can assure you, I'm just sort of touching some of the highlights to assure you that I really am not talking nonsense, like some of my friends say. It really does work. It really works on a very broad scale. And I thank all of you for your attention, and for those of you who've given it a try and seen what's happened with the symptoms you have. So thank you very much.
Pull up a chair and stay away for a minute.